Dear students, I am working out some more problems on maxima minima in this one. Of course, they are statement problems only. Now, look at this one. Find the maximum profit that a company can make if the profit function is given by this one. So, again in this problem the function is given to you directly. You need not frame as you did in the previous session. So, as usual we find the derivative first and the second. Then say here you have to get the maximum profit means you have to find the maximum value. See, that word local will not be used here. That is used only when the function is given directly. For this one, which is considering the profit of a particular company, usually we use the word maximum. Okay. Now, as usual you calculate the derivative. You can write it as say p dash x also, like we were writing f dash x. It is 0 minus 72 and this is 18 2s are 36x. Now, this is the first derivative. Now, let me differentiate for the second time. P double dash x is minus 36 less than 0. So, what is our conclusion? It is the profit is maximum. Okay. Since it is less than 0, it is only for confirmation I am telling you. Okay. Suppose we had greater than 0 here, we would have written that as profit is minimum. So, we want the maximum profit. Any company for that matter expects a maximum profit. So, this shows that the company is attaining a maximum value regarding the profit of that one. So, profit is maximum. Now, to know the maximum profit, you should know the value of x here, isn't it? Therefore, what the usual procedure, let p dash x be equal to 0. What is p dash x here? Minus 72 minus 36 equal to 0. That is 36x equal to minus 72 or x would be equal to minus 2. Now, put this value in the given function. Put x is equal to minus 2 in 1. That is why I have given the number 1 for the function. Therefore, p of x, or you can write p of minus 2, or you can write the maximum profit is equal to, wherever x is there, write the value minus 2. 41 minus 72 into minus 2 and minus 18 into minus 2 the whole square. Now, let me simplify. It is 41 plus 144 and minus 2 whole square is plus 4. 18 4s are, that is 72. So, when you simplify 41 plus 72, hence it is 113. So, the company is having a maximum profit of 113 units or rupees or whatever it is. So, 113 is the profit that is attained by the company. So, when the function, profit function is given, you can directly the same procedure, find the first derivative, find the second derivative and equate the first derivative to 0, get the critical point, but in this case it was not necessary. Now, the next problem is a statement problem. Look at this statement problem. A square piece of tin of side 18 centimeters is to be made into a box without a top by cutting a square from each corner and folding the flaps to form a box. So there is a square piece here, square piece of tin. So in this one, the figure is necessary for you to understand this one. There is a square piece of tin whose, each side, square means all the sides are equal. Each side would be equal to 18 centimeters. Okay, next. Let me come to the next part. Of side 18 is to be made into a box by cutting a square piece from each corner and folding up the flaps to form a box. So from each corner, I have to cut a square piece here like this. Each would be cut like this. Now, what we have to find out is what should be the side of the square piece that is cut. We have cut here in all the corners. What should be the side of the square piece if the volume of the box is maximum? So, taking the volume of the box to be maximum, or when the volume of the box attains a maximum value, what should be the value of what should be the side of the square piece? So what I do is, I take this to be equal to x. Let x centimeters, all of them are x only, x centimeters be the side of the square piece. Okay, let me write like this. So first understand the problem here. I have got a square piece of tin. I have got a square piece of tin, and in each corner I have cut a square piece so that I can fold it. You might have seen this in some, they put the sweets now, like they fold and complete. Here of course the box is without a top. That is one difference here. So a square piece of tin has been considered in all the four corners. So a square piece has been cut and to fold it and to form a box here. The total, the total length was 18 centimeters. We have taken x and x here. So here the length, this would be the length of that one. It becomes 18 minus 2x. Similarly, this becomes the width of that one, or the length and breadth of that one. That is also 18 minus 2x. When the length of the side, the side of the square piece is x. Now when you fold it like this, the height would be equal to x here. So because it's a square piece, when you take the same 2x from all the four sides, it would be, length becomes 18 minus 2x, the breadth becomes 18 minus 2x, and the height becomes x unit here, isn't it? Because the side piece, side square piece that we have cut, it is having side as x centimeters. First let me write that one. Let x centimeters be the side of the square piece, that's enough, because we know that we have cut that one. Let x be the side of the x centimeters, the unit that is given is centimeters. Let x centimeters be the side of the square piece. Okay. Now, you know that the length L of the box, of course, the length L is, you can take it as L here, 18 minus 2x, and the breadth, because we have cut here, the breadth is equal to b, that is again equal to 18 minus 2x, and the height h is x units, x centimeter we can say. And what is the volume of a box? Length into breadth into height, isn't it? If that were to be cube, L into L into L, if all of them are equal to one another, L cube it becomes. But this is different here, length and breadth are equal, height is not equal. Therefore, let V denote the volume of the box, then it is V is equal to L into B into H, isn't it? What is L, what is B? Let me write 18 minus 2x into 18 minus 2x into x. as it is, you can find the derivative, because by multiplying, you can apply the formula UVW. When there are 3 terms here, you can multiply, but I feel better you multiply them and convert that into a polynomial function. It would be easier for you to go for the differentiation. So V would be equal to, first you multiply these two, that is 18 minus 2x the whole square, a minus b whole square formula. 18 square is 324. 2x whole square is 4x square, minus 2 into a into b. 2 into 2, 4. 4 18s are 72x into that x. Only these two I am multiplying. Therefore, v would be equal to, I write in an order, 4x square into x, that is 4x cube, minus 72x into x square, plus 324x. Now, this is the volume. What is that we have to calculate here? We have to find the value of x here, the side of the square piece which we have cut here to make it a box. What is the side of that one? We have to find out. So, let x centimeters be the side of the square piece. Because we have cut it like this, the length of the box becomes 18 minus 2x, the breadth becomes 18 minus 2x, the height is x here. So, we know the volume of the box is L into B into H. Simplifying, this is the statement we have got here. V is equal to 4x cube, V is equal to 4x cube minus 72x square plus 324x. Now, this is the volume. Our problem is to find the value of x here. Now, that figure is not necessary, only to make you understand this one, that figure is necessary. Now, let me consider the derivative of v with respect to x, because that is the variable here. So, 4x cube becomes 3x square, hence it is 12x square. 72 into 2x, that is 144x plus 324. So, this is the first derivative. Now, let me go for the second derivative. D square v by dx square is 12 into 2x, that is 24x. 144 into 1, that is 144. Now, this is the second derivative. Now, this becomes 0. So, our problem is to find the critical point, because you can see that it is having a second degree, there would be 2 values, for which value it attains a maximum thing that we have to know now. Let dv by dx be equal to 0, that implies 12x square minus 144x plus 324 is equal to 0. Now, you observe 12 is a common factor. Take that common factor, x square minus 12x plus here it is 12 2s and 12 7s. So, we are having 27. X square minus 12x plus 27 is equal to 0. When 12 cannot be equal to 0, you have to equate the other one, that is x square minus 12x plus 27 is equal to 0. See, you are familiar with the solution of a quadratic equation. So, you have to split the number 27 in such a way, sum would be minus 12, product is 27. What can be the numbers? Minus 3, minus 9. Suppose you take 9 3s are 27, 9 plus 3, 12. So, this becomes x minus 3 into x minus 9 equal to 0. What does it imply? X is equal to 3 and x is equal to 9. Now, we got 2 values of x here. So, what we have to find out? For which value of x? Because it is given that you have to find the side of the square piece under the condition that the volume attains a maximum value. So, put this value of x and equal to 3 and 9 in the second derivative. One by one we will put. Put x is equal to 3 in the second derivative, that is d square v by dx square. So, what is that one? Here 24 into 3. 24 into 3 minus 144, that is 72 minus 144, you observe it is negative because 144 is more than 72. So, minus 72 less than 0. Here itself we got the information that the volume is maximum. Suppose we had taken this value, we would have got positive. Then you can come to the conclusion at the other point it attains a maximum value. That means that you write at x is equal to 3, the volume is maximum. Volume is maximum, isn't it? That's the information we got from the second derivative being a negative number. Therefore, the side of the square piece. Therefore, the side of the square piece is equal to 3 centimeters. Suppose they had asked for what value volume is minimum, you could have gone to the other value. If both of them had asked, no, you could write that as volume is minimum at x equal to 9, volume is maximum at x equal to 3. Okay? But here only they have asked so that the volume volume becomes a maximum thing, or the volume attains a maximum value. So, we have just calculated considering the value of x to be 3, we see that the volume is maximum. Therefore, we can come to the conclusion that the side of the square piece is equal to 3 centimeters. The next problem is again a statement problem. First read the problem and understand. You have to show that of all the rectangles inscribed in a given fixed circle. See here we have to be very cautious about the words that have been given in the statement. In a given fixed circle, the word given or fixed, sometimes it's only given, sometimes they give the word fixed. Here both of them have beginning. Given fixed circle means the circle remains the same. It doesn't expand or it will not be shrunk, isn't it? That's the meaning of that one. That means the radius of the circle is a constant. So, whenever you consider the radius here, it would be a constant. That is the meaning. When you do the differentiation, think that R is a constant. That is the meaning of that one. So, here in a given fixed circle, the square has the maximum area. So, a rectangle has been inscribed, that is, it is put inside a circle in a given fixed circle. So, there may be any number of rectangles here. No, we are not specifying anything. Of all the rectangles, you can draw any number of rectangles. Of all of them, the square has the maximum area. So, you cannot take it as square. That is what you have to prove in this case. As taking when the area becomes maximum, that is the meaning. When the area becomes maximum, then it becomes a square. That means it will not be a rectangle, it becomes a square. So, when consider a circle here, that is what I have done here. A circle has been drawn with O as the center, R as the radius, and PQRS is a rectangle inscribed in the circle. Now, join the center O to one of the vertices. I have joined it to the R. Now I have taken the length and breadth of the rectangle to be 2x and 2y. So how you have to write? First you have to explain. Consider, this is how you have to write the sentences. Consider a circle with O as a center, R as radius. If you want inside the bracket, you can write R is a constant because it is a given fixed circle. For your reference, you can write R is a constant. Then PQRS is a rectangle inscribed in the circle. See, always you explain the figure. PQRS is a rectangle inscribed in the circle. Now let 2x and 2y be the length and breadth of the circle. Length and breadth of this. I could have taken x and y also. Since the value would be half of that one, no, better instead of having x by 2 y by 2, I have taken it as x and 2x and 2y. Let 2x and 2y be the length and breadth of the rectangle, isn't it? Now come to the figure here. From the center, I have drawn a perpendicular to this one. By a geometrical theorem, when a perpendicular is drawn from the center to the chord of the circle, that divides the circle. Okay. So that means that when the length is 2x, half of that becomes x. This is the breadth here. So when the breadth is 2y, half of that becomes y. R being the radius. Here both x and y are variable depending upon the rectangle size. It may be x may be more, y may be more, whatever it is, both of them are variables. When two variables are there, now how do you differentiate? So we have to eliminate any one of them and try to write one in terms of the other. So from the figure OBR, after explaining and all, we have x square plus y square. X square plus y square is equal to r square. So using the definition, using the Pythagoras theorem here, it is a right angle triangle, x square plus y square equal to r square. So any one has to be eliminated. So how do you write this one? This would be y square equal to r square minus x square. So wherever y comes, you can replace it by x square, y square equal to r square minus x square. So this is the how you have to form this with the help of the data. Now ultimately what has to be proved? You have to show that x is equal to y. That is, it is not a, when it is a rectangle, when the area is maximum, automatically x becomes y. So x is equal to y means the length and breadth are equal to each other. That means it becomes a square. That is what we have to finally prove that one. So here y square equal to r square minus x square. Now our y can be written from this one, because y we need here root of r square minus x square. Now this is what we will be having for y. Now what we have to do? We have to consider the area of the rectangle. What's the formula to find the area of the rectangle? It is length into breadth, isn't it? Area of a rectangle, as you know, is length into breadth. So let me denote the area to be equal to A. A is L into B. A is equal to L into B. L into B. In this case, what is the length here? Length is 2x and breadth is 2y. That is how we have assumed. Now it is 2 into 2, 4 into x into, what is y here? Just now I have written that as r square minus x square under the radical sign. Okay. So this is A at present. So there is only one variable x remaining. You can differentiate with respect to x here. That means dA by dx. See, the remaining procedure is same as I told you. Only the formation of the function, we use the statement and form that one. So differentiate with respect to x. For keep the constant outside. Apply the product rule here. First function into the derivative of the second. Root of something is 1 over 2 root of r square minus x square, r being constant. That is why I repeatedly telling r is a constant, it becomes 0, minus 2x plus the second function r square minus x square under the radical sign into derivative of x is 1. So 2 and 2 can be cancelled. Let me simplify this further, taking the LCM. LCM being root of r square minus x square. So x into minus x is minus x square. This into this, the root is eliminated. So, it becomes r square minus x square. So, let me simplify. The first derivative is 4 into r square minus 2x square whole thing divided by root of r square minus x square. Remember this one? We need this to find the value or the critical point, I can say. Now, let me move on to the second derivative. It is d square a by dx square. D square a by dx square. Again you have to apply the, there we applied the product rule, here we are applying the quotient rule. Keep that 4 outside, denominator, that is root of x r square minus x square into derivative of the numerator minus 4x. Now, minus the numerator r square minus 2x square, derivative of the denominator as usual 1 over root of r square minus x square into minus 2x. Whole thing divided by square of the denominator being a term under the radical sign, that radical sign is eliminated. Now, you need not go on simplifying this one, it is not necessary, keep it as it is, because we are interested to know only whether the second derivative is maximum, less than 0 or greater than 0. Now, let me equate the first derivative to 0, that is dA by dx equal to 0. What is dA by dx? 4 into r square minus 2x square divided by this one, that is 4 into r square minus 2x square divided by root of r square minus x square equal to 0. On cross multiplication this is 0 and 4 cannot be equal to 0. Therefore, we are having r square minus 2x square equal to 0. So, what does it imply? From this one, taking r to the other side, x becomes r by root of 2. So, this value is important. X becomes r by root of 2. Now, we have to put this value in the second derivative and find out whether it is having a minimum value or a maximum value. It is quite a lengthy problem. Now, look at this one. Wherever x is there, write the value r by root of 2. That is, in the second derivative, d square a by dx square equal to 4 you write as it is. See, need not substitute actually. You can look at this and find out whether it is minus or plus. R square minus x square is r square by 2. X is r by root 2. So, r square minus r square by 2, that is r square by 2, it becomes a positive number into minus 4x. So, this because of the negative sign, this becomes a negative number, isn't it? Look here. R square minus 2x square is equal to 0 means 0 into anything, whole of this becomes 0. And the denominator r square minus x square, when you subtract that one, taking r square minus x square to be r square by 2, we will be getting r square by 2, whereas here it is a negative number. So, this is positive. You can neglect that one because it is 0. A minus negative number divided by positive number, it is less than 0. Don't go on calculating, finding the exact value, because for the second derivative, we are interested to know whether it is negative or positive, that's all. Therefore, by writing that value x equal to r by root of 2, I could get that as d square a by dx square, or the second derivative is less than 0. That means that the area is maximum. This is what I wanted. I wanted to know whether it is attaining a maximum value or not. So, it is maximum. But our ultimate aim is to show that it is a square. For what value of, we saw that for what value of x it was maximum, area was maximum when x is equal to r by root of 2. What is x here? It is the semi-length, half of the length here. Now, put x is equal to r by root of 2 in the relation y square is equal to r square minus x square. That is, y square would be r square minus x square means r square by 2. R square by 2. So, r square 1 minus half, that is half, isn't it? R square by 2. So, what does it imply? Y is equal to r by root of 2. What did we get for x there? R by root of 2. What did we get here for y? R by root of 2. That is you can say x is equal to y. And this is what ultimately we had to prove. That is, x is equal to y means it is a square. When does it happen? When the area is maximum. So, this statement problems, no, read it correctly. Read it correctly. Then you have to write the conclusion. X is equal to y. Therefore, it is a square. So, first draw the diagram. With the help of the diagram only you can analyze and try to always you have to eliminate one variable right in terms of the other one. Then you can get the answer. So, we will be working out some more problems in the about the maxima minima, that is the statement problems only in the coming sessions. Thank you.